So you have learned how to declare variables and constants. Now let's take a look at operators. In JavaScript, we have different kinds of operators. We use these operators along with our variables and constants to create expressions. And with these expressions, we can implement logic and algorithms. So here are the different kinds of operators we have in JavaScript. We have arithmetic operators, assignment operators, comparison operators, logical operators, and bitwise operators. Over the next few lectures, you're going to learn each of these in detail. The first category of operators we're going to look at is arithmetic operators. We use this for performing calculations, just like the calculations we have in mathematics. So here we have two variables, x and y. Let's take a look at all the arithmetic operators in JavaScript. So I'm going to do a console.log. Here's the first example, x plus y. That is the addition operator. So these arithmetic operators usually take two operands, in this case x and y, and then produce a new value. What we have here, this x plus y, is what we refer to as an expression in JavaScript. So an expression is something that produces a value. So here's the addition operator. We also have subtraction. We have multiplication, division, and remainder of division. So just like the basic arithmetic operators we have in mathematics, we have a new operator in JavaScript that is exponentiation. It's indicated by two stars, and that is x to the power of y. So these are pretty straightforward. We have two additional arithmetic operators that are a little bit more tricky, so I'm going to focus on those. For now, I'm going to comment out these few lines. You can do that by selecting a piece of code and pressing Command and slash on Mac or Control and slash on Windows. So these two other operators are increment and decrement operators. Let's see how they work. So increment is indicated by two plus signs, and depending on where we put the plus signs, this operator will behave differently. So I'm going to do a console.log of x. X is initialized to 10. So if I save the changes, we see 10 on the console. Now, if I put the increment operator before x, the value of x will be incremented by 1 first, and then we will see that on the console. Let's take a look. So save the changes. See, we get 11. In contrast, if we put this operator after x, we'll see x on the console first, and then the value of x will be incremented by 1. Have a look. Save the changes. We see 10, but at this point, x is incremented by 1. So if we do another console.log of x, now we should see 11. Have a look. Here it is. The decrement operator is pretty similar. So instead of two plus signs, we have two minus signs. And here I'm going to apply this before x. So we're going to decrement the value of x by 1 and then display it on the console. So for this demo, I'm going to comment out these two lines. Have a look. We see 9 on the console because we applied this operator first and then displayed x on the console. So these are all the arithmetic operators we have in JavaScript. To recap, we have addition, subtraction, multiplication, division, remainder of division, exponentiation, which is x to the power of y, as well as increment and decrement operators. The second category of operators we're going to look at is assignment operators. You have already seen an example of an assignment operator. So here we are using the simple assignment operator to assign a value, in this case 10, to x. But we have a few more assignment operators. Let me show you. So in the last lecture, you learned about the increment operator. With this, we increment the value of x by 1. This expression here is exactly equivalent to this. So we read the value of x, add 1 to it, and then using the assignment operator, assign this new value to x. But what if in this example, instead of adding 1 to x, we want to add, let's say, 5? Well, this increment operator will not work. So how can we do that? Well, this is one simple way, but we have a shorthand. We can use the addition assignment operator like this. So line 5 and line 4 are exactly the same. Here's another example. Let's imagine we want to multiply the value of x by 3. So we can write it like this, x equals x times 3, or we can use the multiplication assignment operator like this. So all the other arithmetic operators you learned about in the last lecture, addition, subtraction, division, multiplication, and the remainder operators, all of them have this combination with the assignment operator. All right, now let's take a look at comparison operators. As the name implies, we use these operators to compare the value of a variable with something else. So here we have x set to 1. Let's look at the first comparison operator, that is greater than. So we want to check if x is greater than 0. I'm going to save the changes. Look what we get, true. So the result of an expression that includes a comparison operator is a Boolean. It's true or false. Now, let's look at another example. This second operator is greater than or equal to. So we can change 0 to 1 to see if x is greater than or equal to 1. Obviously it is, so if we save the changes, we get true again. The other operators are very similar. So we have less than, as well as less than or equal to. Now let's save the changes. Look at what we get on the console. So the third item is false because x is not less than 1. It's less than or equal to 1. That's why we got false here. So these 4 operators we have here, we refer to them as relational operators. We also have equality operators. So we can check to see if x is equal to 1. So we have triple equal signs. Let's save the changes. Obviously, x is 1. That's why we get true. Now, if you want to check if x is not equal to a given value, you replace the first equal sign with an exclamation mark. So let's save the changes. The result of the last expression is false because x is equal to 1. So these are all the comparison operators in JavaScript. In the last lecture, you learned about the equality operator. Now, technically in JavaScript, we have another equality operator that is indicated by 2 equal signs instead of 3 equal signs. So you might be wondering what the difference is. Well, first of all, what we have on the top is what we refer to as strict equality operator. What we have on the bottom is what we call loose equality operator. Now, this strict equality operator ensures that both these values we have on the sides of this operator have the same type and the same value. What do I mean by that? Well, in this example, on both sides of this operator, we have 2 numbers. So their type as well as their value are equal. So if we save the changes, we get true and true. Now, let's take a look at another example. This time, I'm going to change one of these numbers to a string. Now, if I save the changes, this expression is going to evaluate to false because here we're comparing a string with a number. So the types here do not match. That's why we'll get false. Let's have a look. Save, and here's false, right? So the strict equality operator ensures that both operands are of the same type and have the same value. Now, loose equality operator behaves differently. So to focus on this operator, I'm going to comment out these 2 lines. So here we're comparing 1 with 1, and we get true. Now, what if we compare 1 as a string with 1? We still get true. In contrast, in the previous example, we got false. So let's see what's happening here. In this case, this operator looks at the value on the left side. Here we have a string. So it will automatically convert what we have on the right side to a string. So it will look like this. And now, because these values are exactly the same, we get true on the console. Now, what if on the left side we have a Boolean? Well, this operator looks at what we have on the left side. Because it's a Boolean, it will automatically convert the value on the right side to a Boolean. So it's like comparing true with true. And if we save the changes, again, we get true. So here's what you need to take away. The strict equality operator ensures that both values have the same type and the same value. The loose equality operator doesn't care about the types matching. If the types don't match, it will convert the type of what we have on the right side to match what we have on the left side. And then it will only check if the values are equal. Now, most of the time, you should be using the strict equality operator because it's more precise and accurate. Now let's take a look at the ternary or conditional operator, which is one of my favorite operators in JavaScript. Let's imagine we want to implement a rule like this. If a customer has more than 100 points, they are a gold customer. Otherwise, they are a silver customer. How do we implement this? Well, first I'm going to start by declaring a variable to keep track of the number of points. So let points, we set that to, let's say, 110. Now we want to declare another variable called type that represents the type of customer. And here is where we use the ternary or conditional operator. So this is how it works. First, we start with a condition. We want to compare the number of points with 100. So we use the comparison operator here, points greater than 100. Now, as you learned earlier, this expression produces a Boolean. So the result of this expression is either true or false. Now, depending on the result, we're going to set this type variable to a different value. So here we add a question mark. Now, if this expression evaluates to true, that means this is a gold customer. So we want to set type to gold. Otherwise, if this expression evaluates to false, we want to set the type to silver. So this is the ternary or conditional operator. We start with a condition. If that condition evaluates to true, we will use this value. Otherwise, we'll use this other value. Now, let's log type on the console. Save the changes. So we have a gold customer. In contrast, if I change the number of points to 90 and save the changes, we'll get a silver customer. All right, now let's take a look at the logical operators. We use these operators to make decisions based on multiple conditions. In JavaScript, we have three types of logical operators: logical AND, logical OR, and NOT. Let's see each of these operators in action. So I'm going to start with the logical AND, which is indicated by two ampersands. So here's the basic rule of thumb. This logical AND returns true if both operands are true. What do I mean by that? Well, let's do a console.log true and true. So we have two operands, they're both true. So the result of evaluating this expression will be true. Let's have a look on the console. Look, here we get true. Now, if either of these is false, the result will be false. So I'm going to change this to false, save the changes. Note that we get false on the console. It doesn't matter which one is false. If I make the other one false or both of them false, we'll still get false. So logical AND returns true if both operands are true. Now you might be asking, what is a real-world use case for this operator? Well, let's imagine we want to build an application for approving loans. So we want to see if the applicant has high income and good credit score, then they will be eligible for loan. So I'm going to delete all this and declare a couple of variables. High income, we're going to set that to true, and good credit score, we're going to set that to true as well. So here we're dealing with two conditions. We want to make sure that the applicant has high income and good credit score. That's where we use the logical AND. So we can declare another variable, eligible for loan, and this is where we use the logical AND operator. So high income and good credit score. Now, if we log this on the console, eligible for loan, we should get true. And here's the result. Now let's take a look at the logical OR. So logical OR is indicated by two vertical lines. And this returns true if one of the operands is true. It doesn't matter which one, whether the one on the left or the one on the right or both of them. As long as we have one true operand, the result of this expression will be true. So here's an example. I'm going to replace this logical AND with logical OR. Now in this case, both operands are true, so the result of this expression will also be true. Let's have a look. So I'm going to save the changes. We get true. Now if I change one of these to false, we still get true. It doesn't matter which one is true. As long as we have one operand in this expression that evaluates to true, the result of this expression will also be true. So this is how we use the logical OR. And finally, let's look at the NOT operator. That is indicated by an exclamation mark. So let's imagine if the applicant is not eligible for loan, we want to consider their application as refused. So we can declare another variable, application refused. Here we use the NOT operator. We apply it on eligible for loan. So this is what happens here. If eligible for loan is true, this NOT operator will convert that to false. So whatever we give it, it will give us the opposite. In this case, if eligible for loan is true, this will convert that to false, and application refused will be false. Because if someone is eligible for loan, we don't want to refuse their application, right? So application refused is always the opposite of eligible for loan, and that's where we use the NOT operator. So let's see this in action. I'm going to change both these conditions to false. So we're dealing with someone who has low income and bad credit score. Obviously, they are not eligible for loan. So let's log this on the console. Eligible for loan. And we can also add a label. So I'm going to add a string, eligible. And here we add comma. Then we apply the NOT operator to set the application refused variable. Let's do another console.log, application refused. And here we log application refused variable. Now let's see what we get on the console. So save the changes. You can see this applicant is not eligible because eligible is false, and application refused is true because it's always the opposite of eligible for loan. In the last lecture, you learned about logical operators. In all the examples you saw in the last lecture, we use these logical operators with Boolean values. But in JavaScript, unlike many other programming languages, we can use these logical operators with non-Boolean values. And that's extremely powerful. Let me show you a few examples. Let's say we have false or true. What do you think is the result of this expression? Well, it's true, right? Now, what if we have false or the string mosh? What do you think is the result of this expression? Well, let's take a look. We get mosh back. What if we have false or number one? We get number one back. So here's the first thing you need to realize. The result of a logical expression is not necessarily a true or false. That depends on the value of the operands we have. In the first example, our second operand is true. That's why we get true back. In the second example, our second operand is a string. That's why we get a string back. And by the same token, in the third example, we get a number back. So when our JavaScript engine tries to evaluate this expression, it looks at each operand. If that operand is not a Boolean true or false, it will try to interpret it as what we call truthy or falsy. So in JavaScript, we have these values which we refer to as falsy. That's not a Boolean false, it's falsy. What are these falsy values? Well, we have undefined, null, number 0, the Boolean false, an empty string, and not a number. Now, we haven't talked about this yet. That's going to come later in the course. For now, just remember, not a number is a special value in JavaScript. And when we're dealing with a mathematical calculation that does not produce a valid number, this value is returned, not a number. Now, we're going to look at that later in the course, so don't worry about it. So these are the falsy values in JavaScript. If we use any of these values in a logical expression, they will be treated as falsy, which is kind of like a Boolean false, but it's not exactly the same. Now, anything that is not falsy is truthy. So, back to these examples. In the second example, our second operand is a string with 4 characters. So this is not an empty string, it's not falsy, so it's truthy. So when our JavaScript engine tries to evaluate this, it looks at the first operand, it's false, so the search continues. Because with the logical OR operator, as you learned in the last lecture, as long as one of the operands is true, the result will be true. Now here in our second example, the first operand is false, so the search continues, hoping that maybe the other operand is true or truthy. In this case, we're dealing with a truthy value, so this value is immediately returned. The same goes for the third example. So here one is not a Boolean true, it's truthy. That's why the value of this operand is returned. Now, what if we have an expression like this? False or 1 or 2. What do you think we're going to get? Let's take a look. We get 1. So this is another thing you need to understand about the logical OR operator. The evaluation starts here. As soon as we find an operand that is truthy, that operand is returned. So here our second operand is truthy, its value is returned, and here the evaluation stops. It doesn't matter what we have on the right side. We could have a million other operands, they are completely ignored. This is what we call short-circuiting. Short-circuiting. Just exactly like short-circuiting that we have in electricity. Now that you understand how these logical operators work with non-Boolean values, let me give you a real-world example of when to use this. So, let's imagine we're building an application and somewhere the user has to pick a color, or we're going to use a default color. Maybe this is the color of the t-shirt they want to buy. So I'm going to declare a few variables. User color, we set that to red. Default color, we set that to blue. And current color, which we set to user color or default color. Now let's read this expression in plain English. User color or default color. That basically means if we have a value for user color, we're going to use that. If we don't, we're going to use the default color. Now let's log this on the console. So current color, we get red because our user has selected a color. In contrast, if the user has not selected a color, let's set this to undefined, save the changes, we get blue because default color is blue. So this is the power of using the logical OR operator between non-Booleans. With this technique, we can provide default values. So if the user has selected a color, we're going to use that. Otherwise, we're going to use our default color, and that determines the current color, which we're going to display on the screen. Finally, the last group of operators we're going to look at is bitwise operators. Now, this really requires me to go beyond the scope of this course. I have to talk about some computer science stuff, and honestly, I don't really want to bore you because these stuff don't really have that much of practical usage in the real world. I'm not saying they're useless, they definitely have their own use, but they're more on the theoretical side, and it's not something that you will use on a daily basis. However, if you're really enthusiastic, I'm going to explain what these bitwise operators are and how they work, but feel free to skip this lecture if you just want to focus on the practicality. So, you know that we humans use the decimal system to represent numbers. So 1, 2, 3, 4, 5. But in computers, these numbers are stored in the binary format, which is a combination of zeros and ones. So let's take a look at a few examples. The number 1 in the decimal system is represented as 7 zeros, 1, 2, 3, 4, 5, 6, 7, and a 1. So we have 8 digits. Each digit is what we call a bit. So here we have 8 bits, which represents 1 byte of information in a computer. Here's another example. Number 2 in the decimal system equals to 6 zeros and then 1 0. There are mathematical formulas behind this for converting numbers between decimal and binary systems. If you don't want to learn the mathematics, you can simply Google decimal to binary converter. Now, bitwise operators in JavaScript or any other programming languages are similar to logical operators, but they work on the individual bits of a number. Let me show you what I mean by this. So I'm going to do a console.log 1 or 2. Note that here we have a single vertical line that represents a bitwise OR. So bitwise OR. Logical ORs have double vertical line. Okay. So when we apply the bitwise OR between 1 and 2, this is what's going to happen. So I add R as the result here. Now, this operator is going to look at each of these bits like this in a vertical way. If either of these bits is 1, the result will be 1, otherwise it will be 0. So here, in both these numbers, the first 6 bits are 0. So in the result, we'll also have 6 zeros. Now, the 7th bit will be 1, because here we have 1 at this position, right? And similarly, the 8th bit will be 1, because here we have a 1. Now, if you convert this binary number to a decimal number, the result will be 3. So let's save the changes. And you can see on the console we have 3. Bitwise AND is similar. So let's duplicate this. Bitwise AND. We'll use a single ampersand for that. Now, the result is going to be something like this. So if both numbers are 1, 1 will be returned. Otherwise, the result will be 0. So in this case, all the bits will end up being 0. Because if you look at these two first numbers, 1 and 2, their first 6 bits are 0. And here in the second number, we have this bit that is 1, but the bit at the equivalent position here is 0. So if we apply the bitwise AND between these two bits, the result will be 0. Okay? So this binary number equals 0 in the decimal system. Let's save the changes and see this on the console. Save. Here it is. So this is the fundamental of bitwise operators. Now in JavaScript, we have a few more bitwise operators, but in the real world, they're not that common. Now let me give you a real world example of when we can use these bitwise operators, so at least they make sense to you. Imagine you want to implement an access control system. So the user can have these permissions: read, write, and execute. Now, we can use 1 byte of information, or 8 bits, to determine the kind of permission a user can have. For example, we can use 5 zeros, 1, 2, 3, 4, 5. We don't care about the first 5 bits, but for the other 3 bits, if the user has a permission, we will use 1, otherwise we'll use 0. So if the user has only the read permission, we will use 1 for the read. And for write and execute, we'll use 0. Similarly, if the user has read and write permissions, we can represent this permission using this binary number. And finally, if the user has all these permissions, we can represent that like this. Now, this is where we use bitwise operators. So I'm going to delete these two lines as well as these few lines on the top. Let's see how we can implement this access control system using bitwise operators. So I'm going to define a constant called read permission. Now I need to set this to a decimal number that is equivalent to this binary number. That decimal number is 4. Again, you can use an online converter to get this. Similarly, I'm going to define another constant, write permission. Now, what I want now is the decimal representation of this binary number. So all these bits or flags are off, only the right flag is on, okay? So this binary number 10 is equivalent to 2 in the decimal system. And finally, execute permission. So what we want is the decimal representation of this binary number. All these flags are 0. Only the execute flag or the execute bit is 1. And that number is 1. Now, I can declare a variable like my permission, initially set that to 0. Now I can give myself extra permissions. So I can update my permission like this. My permission, here we applied the bitwise OR to add a permission, like read permission, as well as the write permission, okay? Now let's take a look at the value of my permission on the console. So we get 6. Now technically, we don't care about this decimal number. We can use the bitwise AND operator to see if I have a given permission. So here's an example. I'm going to declare a variable. Let's call that message. Now here I'm going to use the ternary operator, the conditional operator. Remember? So we start with a condition. We take my permission and use the bitwise AND operator along with the read permission. Now, if this evaluates to true, that means I have the read permission. So let's say we want to display a message like yes. Otherwise, we want to display no. Let me break this up into multiple lines so you can see clearly. So here's our ternary operator. We have a condition. If that evaluates to true, this value will be used. Otherwise, this other value will be used. Finally, let's log this message on the console. So I have the read permission. But if I remove this read permission here and save the changes, now you can see my read permission is gone. So here's what I want you to take away. With the bitwise OR operator, we can add permissions, and with the bitwise AND operator, we can check to see if we have a given permission. Of course, this is just one real-world use case for using the bitwise operators. There are other use cases, but as I told you before, they're really not that common. So if this lecture was confusing, don't worry about it. When working with complex expressions, one thing that you need to count for is the precedence of operators. Let me show you an example. So let's declare x and set it to 2 plus 3 times 4. What do you think is the result of this expression? Well, let's log this and have a look. So we get 14. The reason for that is because the multiplication operator has higher precedence. So this expression is evaluated first. So 3 times 4 is 12, and then the result is added to 2. Now, all these operators you have learned in this section, they have their own precedence. It's really hard to memorize which operators have higher precedence or lower precedence. So when working with complex expressions, you can use parentheses to determine how these operators are applied. For example, here we can put parentheses around 2 plus 3, and this means this expression is evaluated first, so we get 5, and then the result is multiplied by 4. So now if I save the changes, we get 20. All right, let's finish this section with a simple programming exercise. Let's declare two variables. A, we set it to red, and B, we set it to blue. Now, when we log this on the console, obviously we're going to get red and blue, right? Now, what I want you to do is to write some code here to swap the value of these two variables. So when we log these on the console, instead of getting red and blue, we're going to get blue and red. So pause the video, spend a couple of minutes on this exercise. When you're done, come back, continue watching. All right, to swap the value of two variables, we need a third variable. So we're going to declare another variable. Let's call it C. We're going to use that as a backup. So whatever we are storing in A, we're going to put that in that other variable, that is C. Then we're going to copy B to A. And finally, what we have in C, which was the value of A before, we're going to copy that to B. Let me show you. So we declare C and set it to A. So what we have in A, which is red, will be copied to C. Now we want to overwrite A with B. So we said A to B. The value of B is copied to A. Now both these variables at this point are blue. Now finally, we're going to copy what we have in C, which is the original value of A. We're going to copy that to B. So we said B to C. Now, when we save the changes, instead of red and blue, we're going to see blue and red. So this proves that we have swapped the value of these two variables. Now, if you couldn't do this exercise, don't worry. This is because you have not trained your programming brain. And this requires a bit of time. Just like someone who wants to go to gym, they're not going to build muscle on day one. It requires time and effort. Now, to help you train your programming brain, I have designed lots of exercises for you in this course. So as you go through these exercises and look at my solutions, you start to pick up some patterns and techniques to solve programming problems. So once again, if you couldn't do this exercise, don't get disappointed. That's perfectly fine.